Okay, so let's get the second part of this question done. So in the first part, we integrated C2 and we got this as the answer. So now the steps will be to get the area of this C1 and then do C1 minus C2, which will eliminate these empty gaps here, so we can just get the area R. So we have C1 is R equals 1 plus sine theta, and using last time obviously we got our bounds between 5 pi over 6 and pi over 6, which is these points of intersection, and then it's half R squared, which is 1 plus 2 sine theta plus sine squared theta times d theta. So half R squared theta is the formula used to integrate polar coordinates. So then we're going to use our power reduction formula again, which is cos 2 theta equals cos squared theta minus sine squared theta. We have sine squared, so we want to use cos 2 theta equals 1 minus 2 sine squared theta. So then we end up getting that 2 sine squared theta equals 1 minus cos 2 theta. So sine squared theta is a half minus a half cos 2 theta. So if we plug this in, so we're going to sub it in here. One plus 2 sine theta plus a half minus cos 2 theta over 2 d theta. So we're going to simplify this up a little bit. So we've got 1 plus a half here. So we have half still integral. This is going to become 3 over 2 or 1.5 plus 2 sine theta minus cos 2 theta over 2 times d theta. So now we can integrate this. So if we remember how to integrate, so we integrate upwards and differentiate downwards. So we get that this is a half square brackets of 3 theta over 2 plus sine, it's going down to minus cos, so that's actually minus 2 cos theta. Cos 2 theta into minus goes up to minus sine, so that's minus sine of 2 theta, and then this is now divided by the differential of the brackets, so that's over 4 now. So here is what we're working with 5 pi over 6 and pi over 6. So we're going to have to do a bunch of subbing in stuff. So we're going to get half of big brackets, and then we're going to have little brackets. So 3 times 5 pi over 6 over 2 minus 2 cos 5 pi over 6 minus sine of 2 times 5 pi over 6 over 4 minus 3 lots of pi over 6 over 2 minus 2 cos pi over 6. Sorry, just put these in brackets for clarity. Minus sine of 2 pi over 6 over 4. I'm going to get my calculator. Let's fucking do it, baby. So this is a half of, what's this? So 3, so 5 over 6 over 2. It's 5 pi over 4. minus 2 cos 5 pi over 6 is root 3. And minus sine of 2 times 5 pi over 6 all over 4 is plus root 3 over 8. And now I'm minusing 3 pi over 6 over 2 is pi over 4. And then minus 2 cos pi over 6 minus root 3. Then we get in there minus sine 2 times pi over 6 over 4 minus root 3 over 8. Bang, bang. So now we're going to take kind of like terms. So we can see that 5 pi over 4 minus pi over 4 is just pi, right? So we're going to get a half of pi. Root 3 minus root 3 is plus 2 root 3. And then root 3 over 8 plus root 3 over 8 is 2 root 3 over 8. Or root 3 over 4. Sorry, I was questioning reality then. So now this goes to a half of pi and 2 root 3 plus root 3 over 4 is plus 9 root 3 over 4. So C1 equals, so the area of C1, sorry, is pi over 2. Now we times it by the half. Then 9 root 3 over 8. So we're going to get C1 is C1 is pi over 2 plus 9 root 3 over 8. Nice. So now, R, area R equals C1 minus C2. So now it's pretty standard. We're nearly there. The C1 is, we're going to have pi over 2 plus 9 root 3 over 8 minus 9 pi over 2 minus plus 63 root 3 over 8. So pi over 2 minus 9 pi over 2. By the way, we're given the answer in terms of pi and square root 3. So this is minus 4 pi. And then we have 9 root 3 over 8 plus 63 root 3 over 8 plus 9 root 3. Nice. So now we have to give the answer in terms of p root 3 minus q pi. So we have p equals 9 and q equals minus 4. Bang. Easy, baby.